So we have seen the equilibrium in one dimension. We saw some problem of SHM, and now we are supposed to go into two-dimensional equilibrium. Or have you done that? The silk problem?
Sir, which one, sir?
Like this, two masses.
Yes, sir.
We're done?
Yes, sir.
Okay. So there are many variants of this. Let's say if we have. So did you try question from SC Verma?
Sir, yes, sir. I did most of the questions. Sir, I did all the questions, sir, but 4 or 5 questions I have to like do the calculation part, sir.
Okay. So you have done up to like which question number?
So 33, sir.
Oh, great. So then that part is done. Okay. So this is the okay. So we have done the circular motion as well, and we have done the equilibrium as well. We have done the SHM as well. Okay. So we can bring some laws of motion into picture, and so let's say if we have a block, and we have a fixed charge which is exactly above the block at a distance d. Let's say the dimension of block is negligible. So treat the point charge in the block as a point object and take the d as the separation. Coefficient of friction is mu. So what is the minimum horizontal force required to move the block? Find minimum horizontal force So you got the question?
Yes, sir.
So you're supposed to only write the F minimum equals to Fs max.
Oh,
This is mu s into
sir.
n. Yes.
Okay, so we are actually considering the electrostatic force to be only perpendicular.
Yeah, yeah, correct. So that
Oh,
instant, because that's the question. Yeah. So we are considering that
yes.
only. So this will become k q q by d square.
Okay, sir.
So the
Sir,
repulsion
I
will.
was,
Yeah. So rest is simple. You just substitute the
yeah.
value.
Sir, I kind of overcomplicated it with the S
Okay.
section.
No, no, not like that. So this is simple. Okay.
Okay.
The next part we can say is no, the motion is done. So this is slightly more complicated in terms of mathematical calculation. So now the question is equilibrium in three dimension. So let's say we have a ceiling and these strings are of same length, although it looks different.
Sir, like in 3D.
Yeah, in 3D. And at the end of each string, we have a identical mass and charge. All having mass and charge plus charge. So due to repulsion, it will be like something is spread at the bottom, and the bottom will be eventually become the equilateral triangle, right?
Yes, sir.
Because of symmetricity, no other reason.
Okay, sir.
I'm calling this as a vertical. And the angle given to you is theta. So let's say at equilibrium, the angle made by each string with vertical is theta. Of course, in three different directions. So you're supposed to write the, because every mass is identical to other mass and charge. So the net force on this charge will act like this. The net repulsive force will be like this because of this repulsion and this repulsion. And gravity will act like this. So we are supposed to convert this into equilibrium formula, like T cos theta will be mg and T sin theta will be F repulsion. So
Yes, sir.
the FR will be mg tan theta if you divide 2 divided by 1, 2 divided by 1 lead to the answer like this. Okay.
Okay, sir.
Okay. So the whole idea is the FR becomes mg tan theta, and we have to write the FR in terms of Coulomb's law. So we have done for the three charge particles, how to find the net on a one charge given three charges. And the other thing is you have to also apply the use a mathematics to understand the dimension of the separation and all. So L is given, theta is given, but the separation is not given. So what is this separation? Maybe A, but A you have to calculate in terms of L and theta only. that is a difficult part. So can you try finding the FR in terms of
Okay.
theta? So try this out. This is a bit mathematically challenged, but you can do it. Okay,
Okay, sir.
try this out.
Sir, 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 are you there? Sir, can you hear me?
Done? Or you need some help?
Sir, I did it, sir.
Okay, great.
Sir, I'm getting mg into a divided by under root of 3l square minus a square. So, sir, are you able to hear me?
Hello, hello, hello. 1, 2, 3, 1, 2, 3. Am I audible to you? No.
Sir, hello, sir.
Am I audible?
Sir, yes, sir, now you're audible, sir.
Okay, so what I was saying is that if you think of this as L, this as theta, so this length will be L sin theta, right?
Yes, sir.
And now you can draw a perpendicular from here to here because this is like a triangle and this angle is 30 degree because the base is your equilateral triangle.
So we can just directly use the industrial triangle, right, sir?
No, no, we have two dimensions. So we have one triangle, we have one triangle in the horizontal plane. and other triangle is in the three different planes. So the theta is not in the same plane as you think. Theta is only between the vertical line and the string.
Yes, sir. So the vertical line, although we don't know, we can form a triangle between L and
You're saying this angle, no? You're saying this triangle, big
no,
one.
sir.
No,
Sir, the one where you
this
like
triangle.
dropped a perpendicular to that plane.
Yeah, this triangle, like this triangle.
Yes, sir.
But this triangle will give you only this side, no? The dotted line, the brown color.
Sir, the dotted line is there. We have L. Then we can find the perpendicular height.
No, I'm saying is you see the this dotted line
Yes, sir.
is the perpendicular. So the L is there, theta is there. So this will be L sin theta. This one.
So that will be A by root 3, right, sir?
Okay. I got it. Yeah, so you can write in terms of A and L both. So in terms of
Yes.
A, it will be A by root 3. So A by root 3 is same as,
Oh, okay, sir. Yes, sir.
so now A we can write as, so the whole idea is, the A is unknown. It's not given to us.
Okay, sir.
And now once we have the A, what is the FR value?
Uh, sir, I have to replace everything by A again. I mean, by L root 3 L sine theta again, sir.
Yes. So okay, what is the formula for FR? In a triangle, the net force on a charge is how much? Root 3 KQ square by A square, right?
Yes, sir.
You got the root 3, na? KQ square by. And then we are supposed to equate the equation, let's say 3 or 3 and 4. So you can equating to 3 and 4. Okay. So the next part we can do is three-dimensional is also done. So what else we can do now? So you can do like a question like this. What is the force between a rod having a charge Q is spread over its length and the length of the rod is L, and then on the axis of the rod we have a point charge Q, and the distance from the center So now you can see that Coulomb's law, when we write Coulomb's law, F K Q1 Q2 by R square, Q1 Q2 must be point charge, right?
Yes, sir.
But what we can see here that these two are not point charge, so we cannot apply directly the Coulomb formula. Okay.
Sir, so we apply it in like integration, like
Yeah.
separates
Yeah.
the
So,
space.
yeah. So you take a part, a small piece of this rod. So you start from this charge because this is the point charge itself. So we move somewhere here, and then we cut a small length of the rod, and this rod will act as a point charge, right? This part,
Yes, sir.
and this charge you can call it dq, and the distance you can call it x. The question is, we can add the formula of force, but we can add as a df. That's a elementary force, and this we can add as k, k, and then dq. So k dq into q upon x square, right?
Yes, sir.
Now we are supposed to add, because this is x, this must be dx, and we know that the charge is spread over the length L. So dx length will get some charge, so we can relate dq by dx, right?
Yes,
So
sir.
dq by dx is the charge per unit length. This must be q by L because it's uniform.
Yes, sir.
We can add dq equals to q by L. So now we can add as kq. Okay, I should have written some new symbol dq dash because that will be confusing. This is q itself. So dq dash. So kq into, and this is dq dash, just to avoid the ambiguity of the sign, because q dq becomes integrable then, right? But q is a
Yes,
constant. So kq into dq dash, which is q by L into dx, and to get the net force, and to cover the entire length of the rod, the x must begin at a distance of r minus L by 2 and must end at r plus L by 2, right?
yes, sir.
So if you integrate, you can get the answer. Can you tell me the final answer? What is the final answer?
Okay. Sir,
Yeah,
sir, I'm getting KQQ divided by R square minus L square by 4.
yeah. So this is the net force, and this you can also read like this, right?
Yes, sir.
And the way to remember this formula is very simple. The minimum distance from the point charge q and the maximum from the point charge q of the rod, right?
Yes, sir.
So the nearest point is r minus L by 2, the farthest point is r plus L/2, and see this is the nice way to remember the answer. So from the competition point of view, we should know the easier way to remember the things. So let's say if I give you a problem like a rod with point charge, I mean with the charge is spread like this. So now if I just call it this length is also L. So now the question is the force between them will be how much if I bring some charge here. So it's very easy to write K Q Q. The R minimum is L, R maximum is 2L.
Yes, sir.
So answer is K Q Q by 2L square. So we can extend this kind of question to do something like this. So imagine we have two rods, something like this. So I'm keeping everything symmetrical. The only difference is one rod is having positive charge, other is having negative charge, and let's say this angle is uh, 60. So what is the net force acting on the charge Q kept there? So F net on the charge Q is how much? Okay, understood the question?
Yes, sir.
Yeah. So try this out. This is easy one.
Sir,
Yeah, tell me. The answer is how much?
sir, I'm getting KQQ by L square into root 3 by 2.
No. See, it's very simple. The first charge is positive, right? So it will repel,
Yes, sir.
but the second charge will attract,
Yes, sir.
but the value will be same. And
Yes, sir.
this is 120 degree. So the resultant will be bisector because their forces are equal.
Yes, sir.
This is 60 degree. This is 60 degree.
Yes, sir.
F net will be 2F cos 60,
Yes, sir.
which is as good as A. F cos 60 is half, no?
Yes, sir.
So the net
Let me just.
comes out to be same answer, 2L square. This same. Because F value
Sir.
is KQ by 2L square, no?
Oh, right.
The
Yes.
minimum distance is L, maximum is 2L. Okay?
Yes, sir. Okay, sir.
Yeah, so minimum is L, maximum is 2L. That's what it is. 2L square. So with this, we can complete the Coulomb's law part, and now we should move to the next concept, which is called electric field. Just give me 2 minutes.
Okay. So, sir, I'm not able to hear you.
No, no, I was not saying anything. Just a moment. So I went to receive some part. Okay, nevertheless. So what I'm saying is, we are done with the Coulomb's part of this chapter. Now we can move to the electric field. Okay.
Yes, sir.
So let me just check some value.
Sir, are you telling something?
Am I able to you now?
Sir, no, sir. It's not clear.
Am I audible now?
Yes, sir.
Okay. So now we are going to start something called electric field, and we will study first of all what is electric field, and then we will study something called electric field intensity. So electric field, so we have simple definition. It is space any charge. It is space around any charge up to which electric force can be experienced. So it is a space around any charge up to which electric force can be experienced by any other test charge. So if the one which creates the so it is a space around any source charge up to which electric force can be experienced by any other test charge. Okay. So because this is the simple definition. So every charge is capable of creating some sort of aura around itself. And this aura we call electric. Now technically, or you can say theoretically, it is extending up to infinity in all directions. But infinity doesn't mean infinite length. So wherever the field is diminishing to almost zero, we call it infinity. So it could be even a nanometer, which may behave as infinity, or it could be something kilometer, which may behave as infinity, or it could be some light years ahead, which may behave as infinity. So infinity is basically a concept. It has to do with the situation, not with dimension. So
Sir,
theoretically,
you mean like it's relative?
yeah, relative. So for example, compared to 1 centimeter, I can call 1 meter as infinity. But
Yes.
compared to 1 femtometer, I can call even 1 millimeter as infinity. Compared to 1 femtometer, I can even call 1 micrometer or 1 angstrom as infinity. So these two are relatively infinite. So one is really small, then the other we call it infinite. So we'll come to that.
Sir, are you speaking something?
No, no, I was not saying something.
Oh, please.
So theoretically, it extends up to infinity. So theoretically, it extends up to infinity. but practically it is not so to be concerned. Okay, fine.
Yes, sir.
Just a minute.
Okay.
So electric field is a constant, and every charge will have the field around itself, which will extend from the charge up to infinity. What you need to also remember that we do not define field at a location exactly at charge. So charge will create the field. So it begins from as good as the charge, but not exactly at the charge. So it begins from the charge and it extends. So you can say if charge is something physical quantity, the field will start from the surface of the charge. Anyway, this is something which we don't know. So now mathematically, what we need to understand is called electric field intensity, or it is also known as electric field strength. Okay, so these two are the same thing, just a way of saying. And intensity basically refers to how strong the field is or how weak the field is. That is what we are trying to refer to. So electric field intensity or strength is measured in terms of force itself. So if we have some charge Q, we know that it will create some hypothetical field around itself. If we have a charge Q, it will create the field around itself. And I would like to know how strong the field is at a location R away. So I want to know that how strong the field will be if you are at a distance R from the given charge. So the whole idea is let's bring some test charge at the location P and calculate the force. The answer will be KQQ by R square, or in vector form you can write as KQQ by R cube into R. Okay.
Yes, sir.
Now to understand the electric field strength at a point P, the step is first bring the test charge and calculate the force on the test charge. Now the force per unit test charge is called electric field intensity, and the idea is we must take the limit of charge tending to zero. So the electric field at a point P is limit Q tends to zero, FQ by Q, and if you substitute the value, only Q will get cancelled out. So you end up getting something like this, or You can also rewrite as kq by r square into r unit vector, or maybe you can write as er. And in scalar form, the value will be kq by r square. So we are trying to find the electric field due to source charge at a point P. So to first we bring some charge Q and we find the force. And once the force is calculated using Coulomb's law, we divide by the charge brought there to get the intensity. So the while solving the numerical, we will not do like this. Rather, if I bring a plus 1 Coulomb charge, the force will be how much? KQ 1 by r square,
Yes.
which is having the formula same as the electric field. So
Yes.
finding the electric field intensity at a point is as good as finding the Coulomb force at a point, assuming a charge of plus 1 Coulomb is kept there. So what
Yes.
we can write? So finding electric field intensity at a point due to given source charge So finding electric field intensity at a point due to a given source charge is equivalent of finding force between source charge and plus 1 Coulomb, assuming to be kept at that point. The next part we need to know is direction. So direction of direction of electric field should be taken in the direction of direction of electric field should be taken in the direction of that simple. So the moment someone is asking you, let's say we have a charge on a vertex of an equilateral triangle. If I call the charge as plus q, and the point P is here, which is empty location. So let's say I'm asking you what is the electric field at a point P, or just find the value, not a vector set. So what you will do is to solve the problem, just assume plus 1 coulomb charge and apply the formula of Coulomb's law the way you have done already before. The question is same as the previous question of finding the Coulomb force. So this will repel,
Yes.
and this will repel, and the only difference is instead of calling it a force, we call it electric field E. So let's say this force is E, this force is E, and the net force will be at bisector. So EP will be equal to 2E cos 30, and this will be root 3, right? And the value for E will be how much? KQ by, so KQ into 1 coulomb upon A square. The answer is same as before. The only difference is we have only single charge instead of product of charges that we used to have earlier, right?
Yes.
So now I will not be doing this question again because I have done a lot of question of Coulomb's law. So what you're supposed to do is apply the same law, and the point at which you're trying to find the electric field, just put plus 1 charge, do the calculation of force, and that is the answer of field itself. Okay. But still, to give you some practice, I would like you to solve at least one question. So imagine we have a triangle. Yeah, triangle we have done. So, and we have charges Q. So what is the electric field intensity at the point P? Do this.
So,
Yes.
sir, I'm getting KQ by A square into 1 by 2 plus root 2, sir, along the diagonal.
By AQ by A square into,
1 by 2 plus root 2, sir.
yeah, that's the right answer. So you know this how to do this. Okay.
Yes.
So finding the electric field due to the discrete charge is similar of solving the question of Coulomb's law. Now we'll talk about the force relation between force and electric. So we know that if we have a charge Q, then the field which is already existing at a point P will be how much? The field at a point P we know is KQ by R square. So the moment you bring some charge here, Q, the force will be KQQ by r square. And if you compare, you can clearly see that the F is nothing but the charge brought into the field existing already. So force
Yes.
on a any given charge is equals to charge multiplied by the electric field due to all other charges except that charge. Like the one which will experience the force should not create the field. Or you can say in other words, the one which will experience the force should not have contribution to the field uh, for the same. So the force is equals to Q multiplied by electric field vector. So the force and the electric field vector may be parallel or may be anti-parallel depending on whether the charge is positive or negative. So if we assume the charge experiencing the force is positive, then the force will be parallel to the electric field. And if charge is negative, the force will be like this. Okay.
Yes.
So the positive charge always experiences force in the direction of field, and negative charge experiences the force in the direction opposite to the field. And a neutral object will never experience electric force. If the charge is zero, no force, right?
Yes.
So if we have a neutron, then it will experience no force.
Yes.
If we have a proton, then it will experience force in the direction of field. And if we have an electron, it will experience force in the direction opposite to the field. Okay.
Okay.
So let's say so we have something like this. So let's say we have some radioactive material, and it emits alpha, beta, gamma rays, some sort of rays. And in the space, we have already existing electric field, which is created by some charge distribution, which we don't know. We are not aware of who has created the field, but we have. Okay. So now, if this is the electric field, so there are many particles which is emerging from the this you can say mystery box. So some particle is passing through without diminishing, deviating, so it goes straight. Some particles coming and going this way. Some coming and going this way. So if I call the path name as A, B, CD. And it is given that the particles that are coming out of this is ABCD. So we have alpha rays, proton, gamma ray, uh, and beta rays, beta minus. And let's say one hypothetical particle, maybe uh, Li plus. Maybe I can take. Oh, fine. H minus. So we have 4 particles. You can see we have particle 1. Questions: can you identify the path of each particle? Ignore gravity. So if the electric force is the only force, then which path belongs to which particle?
Sir, is gamma rays like an electrically charged?
Gamma rays is electromagnetic wave. Electromagnetic wave, no charge. Alpha rays are basically helium doubly ionized nuclei is called alpha. Beta is electron, and proton is proton. What is plus charge, and H minus is minus charge.
Okay. Sir, the no charge, the gamma rays will be of E,
Yeah,
and
right.
sir, the proton will be of C,
Proton will be of C. Yeah.
and then the alpha particle will be of D.
Yes.
Sir, so both beta and hydrogen have like equal negative charge.
Pardon?
So both beta rays and the hydrogen is have the hydrogen
Yeah.
ion is having like equal negative charge.
So we have to think about the mass of both,
Right?
because to decide the deviation, what we are assuming in this question is that everyone is coming with same velocity.
Yes.
So deviation depends on the acceleration, right?
Yes, sir. So
Yeah.
hydrogen has more mass than zinc, so it will be more difficult to turn it. So that will be of B, and beta rays will be of A.
Correct. And similarly, in case of C and D, so C will be belonging to alpha, right?
Yes, sir.
And D will be proton.
Proton.
So we do not decide by the force, rather we decide by the acceleration, and we must look for the acceleration and
Okay.
who will deviate in what direction. Okay. Okay. So the force depends on electric field, right?
Yes, sir.
If we have a particle charge, the force on this charge will be due to the field in the vicinity of the. So in the vicinity of this charge, whatever is the value of electric field will create the a local force. So force depends on the localized electric field. Okay. So what that does it mean is, if we have two charges Q1, Q2, so the force on Q is actually applied by the charge Q2 into electric field due to the first charge, and force on Q1 is basically due to Q1 into electric field of the second charge. So what I'm trying to explain, that force is a local phenomena, and the field in your vicinity can only apply force on you. So let's say if I create a situation, so if we have two equal charges Q and Q, and we have a center, so if I ask you what is the electric field at the point P, so the answer will be 0. So the electric field at the point P is 0, yes or no?
Yes, sir.
So no matter which charge you bring here, it will never experience any force because the field itself is absent. So force on a charge Q or any charge Q will be 0 at a point. Because to experience the force, we must have some existing electric field. So if for some reason the field is absent, we say the force is not possible. Okay.
Yes, sir.
So when it comes to force calculation, we must look for the field first. And assuming that the field is absent, so assuming that the field is absent, we can say the force is absent. Force is not possible. So no matter who is going there, the answer will be 0. So similarly, if you remember, we were solving question like Q1, Q2 are two charges, and these are fixed charges. So the field will be 0. Let's say both are positive. So somewhere in between, we will have a point at which the field will be 0, and
Yes,
that
sir.
point will be. So we know the answer, which is under root of. So the ratio will be proportional to the charge ratio under root. Okay.
Yes.
So the whole idea is, at this point the field will be.
0.
So if I bring any charge, no matter what value, the force on Q naught will be 0, because it is coming to a point where no field exists. And to
Yes.
experience force, the existence of field is necessary. Okay.
Yes, sir.
So now, just so imagine we have to solve a question in which. So if you remember the same question, a block which is kept on a rough horizontal surface of mass m and charge plus q, And now what we are doing is an electric field exists in the direction parallel to the plane or the horizontal surface. Okay, so now, so I may ask you a question that find E minimum to move the block. So if you draw the FBD, the electric field force will be like force right,
Yes, sir.
and the friction force will be backward.
Yes, sir.
Move the block, the QE must be equals to Fs max,
Yes, sir.
but the normal is still balanced. I mean, normal is equals to mg only.
Yes,
So
sir.
you can write as mu mg. That's it. So the E minimum turns out to be how much?
Mg by Q.
But to make this problem a slightly complex, we can draw something like this. So let's say we have the angle theta, we have a block. So what we are doing is we're creating uniform electric field on the in the horizontal direction. So now the field is towards horizontal direction, charge is Q, and the coefficient of friction is mu s. And it is given that the angle of the plane is exceeding the mu s, so the theta is more than angle of repose, which means theta is more than angle of repose. What is angle of repose? Do you remember? The minimum angle at which
For
the,
not sliding.
yeah. So now the angle is more than the sliding angle. Okay. So it is, so in general it will try to go down, but I'm applying the electric field, horizontal field. So it will create a force which can balance. So question is find E minimum and E maximum for which the block will be at equilibrium. That's the question. So it is basically challenging problem. So you have to work hard and you have to work something to get done. So try this question, then I'll help you. Maybe you can take 10 minutes. That's totally okay, but try as much as possible. Okay. So we have done question like this in the chapter of friction, and there the field was not there. We were applying some force F like agent. Now here the F becomes Q into E. That's it. Okay.
Yes, sir.
So try. Go ahead.
So
Yeah. So what is the
sir,
minimum value? The minimum part?
sir, I'm getting the minimum value as mg sine theta minus mu mg cos theta divided by q into cos theta plus mu sine theta.
Okay, just let me do this again. So here the block is here.
So like the friction will be downwards in this for minimum case.
For the minimum case, the block will tend to go down. No? Friction will be acting upward. No?
Oh yes, sir, yes, sir, yes.
So the tendency is to go down. And now we have force normal mg cos theta, right?
Yes, sir.
And we can also write QE further. So we can write n plus, sorry, n equals to mg cos theta plus QE sin theta, right?
Yes, sir.
And QE cos theta plus mu s into n is mg sin theta. So QE cos theta is mu s into mg cos theta is QE sin theta. QE into cos theta plus mu sin theta is mg cos theta. Sorry, this is mg sin theta. This is mg sin theta. Right? So mg, okay, here. Mg sin theta minus mu cos theta. So the E minimum turns out to be mg upon q sin theta minus mu s cos theta upon cos theta plus mu s. And similarly, the E max will just change the sign.
Yes, sir.
So is this what you're getting?
Yes, sir.
Very good. So this is how we can solve the various questions. The electric field will do nothing. It will apply one force, and you have to just accommodate that force in the FBD, and rest will be as good as what we have done so far. Okay.
Yes, sir.
So let's say we have a situation in which there is a wall, and there is a point of suspension, and exactly at a point P, which is L below the O point of suspension, so we have a thread of length L, and mass is M. Now, the moment I give some charge to the given mass, so let's see if I give a, so now what I'm doing is at point P, we have a fixed charge capital. This is a fixed charge. And this is given a charge. So what will happen? Both will repel each other. And the string is, you can see, suspended at the point O. So after some time at equilibrium, The string will be something like this, right?
Yes.
And this is a fixed charge, and this is the charge on the pendulum. This is also length L given. This is theta. So because of the repulsion between the two charge, what will happen?
Sir, it will tend to
It
go
will-
away.
Yeah, so it will push like this,
Yes.
and tension will act like this, and gravity will act like this, right?
Yes, sir.
So find tension. Can you find the tension,
Okay.
or write the condition for equilibrium?
So,
Yeah, tell me.
so I'm getting t value was mg minus kq cube by 4l square sine theta by 2 divided by cos theta.
So let's say if I call this angle as this angle comes to how much? 90 minus theta by 2.
Yes, sir.
Because if you add all three, you'll get 180, right? And because
Yes.
it's isosceles triangle, so we can say this is angle is same. So now we have this angle, and this angle will be also 90 minus theta by 2. Why? Alternate angles.
Yes, sir.
So because you know the two angles, so this angle is 90 plus theta by 2, because the sum of the angle of a line is 180,
Yes, sir.
and similarly this will be 90 plus theta by 2. So because we know all angle, so solving question like this, the best way is apply Lami's theorem.
Yes, sir.
So you can add t upon sine 90 plus theta by 2, which is cos theta by 2, is mg upon sine 90 plus theta by 2, which is again cos, sorry, mg upon, yeah, cos theta by 2. And that is equals to f resultant, I mean repulsive equals to upon 90 plus 90, 181 theta, so sine theta. So basically we'll get 5 1 theta, but that is same. So if you use the first two equation, you can get the answer. T is coming to be mg only. So tension is same as mg. Okay. And the FR turns out to be mg sine theta by cos theta by 2. So we can attach 2 mg sine theta by 2 into cos theta by 2, which you consider 2 mg. So F repulsive comes out to be 2 mg sine theta by 2, and this we can add from Coulomb's law. KQ by 2L sine theta by 2 whole square. Okay.
Yes, sir.
So this is what you did. I hope so.
Sir, I didn't do it by the Lami's theorem
Okay. So
method.
yeah, you applied the x and y component, right?
Yes, sir.
Okay. So this is the easy way of doing this. You can of course do it by the way you did. Okay. So that's
Okay.
totally okay. So this is the one of the question. This is the question from the uh, Coulomb's law itself, but just I forgot to mention. Okay. Just so we can do something like a, projectile motion. In electric field only. So imagine if I create a, I mean, this is called capacitor, but let's say you don't know about capacitor. What you need to understand is that we have two metallic plates. So we have two metallic plates, and one plate is given a positive charge. Okay. Other is gain negative charge. And the plus and minus charge will create the kind of uniform field across the space between the plates except the edges, and we can think this uniform field something like this. So beginning from the positive and ending towards the negative. So any charge in this field will experience the force in which direction? Either downward or upward.
Yes, sir.
So if a positive charge will enter this space or this region, the force will be downward or upward.
Downward, sir.
Yeah. So let's say we have a positive charge which enters with velocity v naught at a height h. So direction is x-axis.
Sir, I'm not able to hear you. Sir,
Am I audible? No.
sir, now you're audible.
Recording in progress.
Am I audible now?
Yes, sir.
So now we can write the similar equation that we did in the projectile motion. The ux is v naught, uy is 0. So now the important question is what is ax and what is ay? So you can see clearly that if I call the electric field strength as E, let's say E is the value. So AX will be how much?
So 0.
But what about AY?
It will be QE downwards.
QE by M downwards.
Yes, sir.
So now once you have the AX, AY, you know what to write. So what will be there for time of flight? So for time of flight, because it will eventually move downward and will hit the plate somewhere. So we can write y minus y naught equals to uyt plus half ayt square. The y is 0, the y naught is h, the ey is 0, ay is minus. Basically, I have to put minus n if I want to remove the arrow. So minus QE by m into t square, right?
Yes, sir.
So you can call this as G effective. So let's call it QE by m as G effective. And then the answer will be same. So this is capital T, let's call it capital T. So T turns out to be 2h by QE by m, which is same as 2h by G effective, which was the old answer, right?
Yes, sir.
Similarly, you can find the range V naught into T, that's it. So you can get all answer. And but if I choose the base as the origin and this as the x-axis and this action is y-axis, we can add the x coordinate at any time t. This is x comma y. So x coordinate will be v naught into t and the y coordinate will be uyt plus half ayt square. Obviously, I have to write y minus y. So y minus y naught is h, 0 plus 1 by 2 minus QE by m into t square. So y turns out to be and from here we can get t equals to x by v naught. We are trying to find equation of trajectory. We have done this before, but let's do it again.
Yes, sir.
The trajectory means relation between x and y, and we can have t as x by v naught whole square. So y equals to okay.
Yes, sir.
This is the equation of trajectory. It is like an inverted parabola. So that's so you can do any motion analysis using the concept of electric force. So let's say similarly, if I have a parallel plate capacitor, with a similar arrangement of plus but now what we are doing is we are projecting a charged particle close to surface. So this is plus charge, so definitely the minus plate will try to attract it. So even though if we throw at some angle theta, it will try to come back here, right?
Yes, sir.
So again, the AY will be minus QE by M, and I'm taking Y as up. So you can write a UX equals to B naught cos theta and they can also find the time of flight. So no need to solve because you know the answer 2 UAY mod of AY, the value of AY.
Yes, sir.
So the formula will just get modified. You can apply the same thing for finding the range, time of flight, and so on. The whole idea is we can ignoring gravity. So we are solving question ignoring gravity. If you want to add gravity, the net force becomes QE by mg, QE plus mg, and then the AY becomes minus of this value. So if gravity is taken into consideration,
Okay.
so the AY will be equals to minus. So with and without gravity question may come. You have to be mentally prepared. Okay, both things are possible, and therefore we need to solve question accordingly. So there is a variety of question which are based on the kinematics, and you just need to practice, and it won't be very difficult. Okay,
Yes, sir.
let me see if I can give something more. So I think now we have to go to the calculation of electric field due to the continuous charge distribution. And that is a big chapter. That is a big topic. We'll do the calculation. In fact, various calculation. And now we are going into the world of integration. Okay.
Okay.
So the next lecture will be all about integration. You can just brief yourself with integration, basic various formula, and then we'll continue. Okay. So
Okay,
I
sir.
think we're done with the rotation, right?
So,
Yeah. Rotation we are done, no?
yes, sir.
So now we have to move forward, and after electric field, we have to also go to the Gauss law, and then we'll finish together both the topics. Okay. Again, this is the biggest chapter, so don't worry, it will take some time. So what I'm planning is that I will finish your 12th syllabus first completely, and once 12th is done, we'll go back to the remaining portion of 11th. Okay. So
Okay,
that
sir.
easy only. And meanwhile, I can give you link to the YouTube videos. You can watch those videos to understand those chapters. If you have time, you can complete both. Okay.
So
And
YouTube videos.
yeah, like I'm taking, say, I have taught some chapter in other batches, right?
Yes, sir.
So those videos are available. You can watch the same topic but in other batches. So in that way, we can continue the electrostatics, and meanwhile, you can complete the 11th portion, and then at the end of the 12th, you can revise those things. Okay, so we can solve more and more problems. So this is up to you. You can choose of doing or not. Okay.
Yes, sir. Sir, these YouTube videos, the links.
I will send. I will send. I have link. I will send.
Okay, sir. Thank you, sir. Bye, sir.
Good night.